Hello, is this working? Cool. My name's Jason. I'm here to show you how to build this thing, which is basically a school of fish swimming through the sea with a camera kind of in the middle of it. And this is something I sort of stumbled across playing around with Nvidia Flex. There's something kind of similar to this called Boids, which is like the simulation of flocking. That's not this, but this is sort of an approximation of it, or something that's kind of faux Boids. If you check out this person here, David Braun, they've got a really cool tutorial on using Boids for flocking simulation like this. It's totally amazing, all done in GLSL and various other bits and bobs with shader builder, etc. Totally awesome. Highly recommend going to look at that if you're into your GLSL and you know, the more complex stuff in TouchDesigner. What we'll be doing today is completely operator based, Nvidia Flex instancing, some stuff with the object chop to get this kind of fish orientation, and then a bit of camera work as well. So this is kind of the network as it stands. So we've got our flex stuff, and this is our liquid kind of being instanced, and then we follow a ball around to kind of create this flow, and then we've got our chop stuff, which does the orientation of the fish, keeps them pointing all in the same direction. Then we instance our fish here with this FBX off of Sketchfab, which I will link in the description. And what else? We've got the camera itself here, and then just some scaling stuff with noise and a general, very standard render network there. So what I'm going to do is I'm going to pop out here, I'm going to make a new container, I'm going to start this from scratch and see how we go. So I'll create a container first, and I'll just make this the right size so that we can reference it later. So that's just going to width and height, 1920 by 1080 in the top corner. I'll make this a bit bigger here. So the first thing we want to do is build our Nvidia Flex network and get those fish instanced, well, little spheres instanced, and get them following this ball around in space, and I'll show you in the geo how that's going to work. But the first thing we need is a sphere here. I just reduced the detail on this just in case it creates any overhead, because it doesn't really matter, because we're going to instance what comes out of Flex anyway, so we're never going to see this once it's instanced. I'm going to make that the size of 0.1 with a transform SOP, and then create a null, and then I'm going to create an actor, and this is going to generate all of our points in the fluid. So we're set to fluid here in the Flex tab, which is fine. I don't think we need to change anything else in here. We'll find out when we come to it, and we're going to use this instancing page in a sec. So to do our instancing, the easiest way I find is just to create a noise, pop monochrome off, and go to 32-bit float, null that off. Also set this offset in noise to 0, then that way all of our points aren't set up here, they're sort of still around 0, which makes things a bit better, a bit more centered. And then we'll set this to 80 by 80 wide, and that will create us 80 times 80 fish, which is 6,400 fish. Very exciting stuff. So pop this null into our instancing, translate op, and reference RGB. And this should, if I go to here, instance our fish. So if I just zoom out, so there we go, we've got a nice ball of fish. Also, the other thing we should do here is I tend to find it works a bit better with random GPU on there instead of the Perlin noise or the simplex noise. We sort of get, I don't know, just a bit of a better result in the end. So what else do we need to do? We need to create an Nvidia Flex comp. So this is the thing that does all of the fluid simulation, and we're going to change lots of settings in here to kind of get things to flow exactly how we want, and we'll come to that in a second. The other thing we need is a force, and this is the thing that the fish are going to follow. So I'm going to create another sphere, and transform that. We'll probably have this as 0.2 for now. We'll see how big it ends up being. Null that off and then pop this into a force like this. So I'll just center this up. Oh god, I'm making a mess. Put that there like that. Display this stuff, and then in here we'll want to display this as well so that we can see it in our geo. It's just for debug purposes really. The next thing we want to do is have this be moving around so so the fish can follow it. So what I'll do is I'll just pop open a geometry viewer here so we can see what's going on a bit, and then make this a bit smaller. And what we're going to do is have this follow a path. I tend to like, you can do this with LFOs, and there's a few other different ways to do it, but I just like using a circle SOP and setting this to, what do we need it on? ZX plane, and I normally have it at 5 radius in each way, so that'll create a 5x5 circle here, and then we can have our camera, our force ball follow that. So I put a null here, spread this out a bit, and go in here in the transform page we've got path SOP. We can pop this in here, and then we can turn off, I don't think we need to bother turning anything off here actually. Then we can go ABS time in position, .seconds, and the value I've been using for this particular project is .seconds times 0.25, and that'll get this ball moving around. And this is all these things are going to follow this in a moment. The other thing we can do to make things a bit more interesting as well is put in a twist SOP here. And what this will do is just give us a bit of a varied path. So the value I've been using for this, where I've written it down somewhere here, I have this on the Z axis, and then a strength of 32. And you'll see that kind of creates this, if I put this on wireframe, creates this nice path for the ball to follow around. Also, we need to create some more points here so that we get a nice smooth movement from our ball. And there it goes. So that's our force rolling around. What else do we need here? So that's the thing we're going to follow. We need to set our force field up. So we're going to turn this on. And what we want to do is have the fluid be attracted to it, so you can give it a negative strength here. So I've gone for -10 for the negative strength, so that'll draw our fluid in, and then a radius of 12 is kind of what's worked for me with these particular settings, and you'll be able to play around with it as much as you like once we get the basic setup going, and you can vary it as widely as you like, but this is what has worked for me to be able to get that particular animation. So let's see how this looks in general. So our Nvidia Flex solver, we need to set our gravity to 0 because we just want them to follow that ball. We don't want our fluid to fall to the floor or fly off anywhere else. So let's see what happens now. I think this might sort of get us somewhere where we want to be. Yeah, okay. So we've got our fluid following the force, but it's all a bit chaotic at the moment. It's acting very fluid-like and not very fish-like. So what we can do is in our properties on the solver, we can spread the fish apart a bit. So we can change this to something like 0.6, and that'll sort of spread them out. It increases their radius basically, so it gives the illusion that they're sort of swimming further apart. Now we've lost a lot of points everywhere, but once we get these settings right, things won't tend to fly off into space, hopefully. The other thing we need to do is clamp the speed of our fish as well, so that they don't catch up to the ball too quickly, so that they actually follow it instead of being as fast as it. So we can clamp our speed. What I found is 0.7 has worked quite well for this. Here, let's see what's going on in our viewer. Moving nice and slowly, which is fine. Max acceleration I have on 200, and cohesion set to 0 for now. We can play around with that because it's kind of good for getting things flowing in a particular direction, the cohesion, and it's used in that Boyd's simulation as well. Pardon me. What else do we need? Smoothing. So we pop our smoothing up to 10, and that'll kind of, oh, not 100, 10, that'll kind of give us a bit of, it says it smooths, but I've found it sort of gives me a little bit of, gives the fish a bit of a wiggle, sort of. I don't quite understand how it's working, but that setting's worked very well for me. And then the collision distance we want is 0.4 as well. And that'll kind of make them collide, but hopefully not overlap with each other too much. Let me just check we've got all of our settings in there correct. Okay, so that's good. Let's reset this and see where we go now. So none of our fish have run off into the distance. They're sort of following the ball. The ball does exist inside of the massive fish sometimes, but you see how they'll sort of start to flow around quite nicely. So that's great. I think that's everything we need set up on there. So we've got our basic simulation working now. So the next thing we need to do is actually create our fish. Instead of these little things here, these low quality spheres, we'll change this into a fish SOP geo instanced in a completely different geometry compared to this one. So the first thing we will do is import an FBX, and I'll put a link for this. Oh, that's my videos. Where's my fish tutorial gone? What I'll do is I'll import, put a link up to this particular FBX, but you can use anything you like. So this is just a fish FBX off Sketchfab. There it is there, it's a lovely little fish. And I think we'll also need the texture. I'll just copy this in anyway because it just makes it easier to reference. From here we can use an import select and then dump our FBX in there. And that should give us here on the geo path the fish that we need. The next thing you'll notice is our fish is pointing downwards. And what we want it to be doing is pointing in the negative Z direction to sort of allow it to follow correctly. So on the rotate here, we can set this to -90. And then I think probably on this one, we can whip it around to -180 or 180 if you like, whichever way around you prefer. Then we can stick on, oh, we can just do it in here actually, another transform. We'll set this to maybe 0.2. We'll see how that goes in terms of fish sizing. We can also turn this off because we don't want to render our fish here. Then a null and your standard kind of geo here. And what else do we need? We need a camera. We'll just do this for now, but we're going to set the camera up a little bit differently later on. But this is just so we can get something rendering. Then we'll set up a traditional render network with a render top. We'll have this reference the parent, I think it's me.parent brackets width and me.parent brackets dot height. Lovely stuff. So we've got a camera in the middle with our fish just floating there, lovely. We'll null this off and we will pop in a background here. I like to use a constant and an over, but you can also use an RGB key if you so wish. This is just so, I don't know, in case I ever want to change the background in a different way. I've sort of already got something set up, so set that to black like this. So now I've got a background and then we can view this on here like this. Okay, lovely stuff. So let's change all of these things into fish now. How do we do that? So there is a very cool top called Nvidia Flex. And what this will do is give us a texture that contains all the positional information coming from this actor here and the Nvidia Flex thing as a whole, depending on which one of these comps you reference. So what we can do is in here we've got Flex, Solver or Actor Comp. We can drag this in and now we've got a texture that contains all the positions of our fish in the simulation, which is amazing. We can null this off and call this fish pos, like that, and use this in our instancing page for our fish model on the translate op and put RGB. Okay, there we go. We've got loads of fish flying around instead of spheres. So what that means is here we can turn this off because we don't need to ever see those spheres again. Let me just make this geo viewer a bit smaller. Is that going to let me? Do I even need it? Let's close it for now, just so we've got a bit more room to work with. So there we go. We've got fish floating around. What else do we need to do? I think we need to make these a bit smaller, don't we? So let's go there. Maybe like this. Maybe even a little bit smaller. Let's go with 0.1 on this transform for the size of the fish for now. So what else do we need to do? We need to texture our fish as well. The simplest way to do that is to reference this fish texture that comes in with the FBX and apply it to a material. So we can create a Fong material. I like to null my materials off just in case I want to swap them out or switch them for whatever reason. And then we'll null off this texture as well just in case we want to do any work on it. Bring this down here and drop it onto our Fong as the color map. Lovely. So now we've got textured fish flying around, not doing quite what they're supposed to yet. What else do we need to do here? So we've got our fish flying around following that ball that you can see just in the background there, but they're all facing in the same direction at the moment. And what fish tend to do when they swim is, and they school together, they all tend to follow the same direction. They all face in the same direction. So there's a very cool chop called the object chop, and Matthew Reagan, who we all know and love, created some nice operator snippets for this as well. And if you go in here, if this doesn't crash, they've created a bunch of different examples that show you how to use the object chop to get orientation like this, and this is exactly the technique we're going to use. You can also get orientation and distance all from your instances just using this object chop, so it's pretty amazing, and you can even do collision stuff with it as well. So I'd highly advise going to look at these snippets because they're super useful and very, very powerful. So what we're going to do is have all of our fish look in the direction of this force here, the thing that we're following. So we can do that. First we need to get the position of this at all times, and we can do that with this object chop. So we can drag our force on as the target object, and then in the output tab here we can go measurements and position, and now this gives us the position of our force wherever it is in space. So now we've got the position of the thing we want to look at. Super. The next thing we need is the positions of all of our fish, which we've got right now in a texture, but we need to convert this into chops so we can use this object chop. So what we will do is go chop to top, and this gives us just the first row, so we need to go crop, tab, and full image here. Now that gives us the RGB XYZ positions of all of our fish, but not in the format that we would like for the object chop. So we're going to shuffle them and put them into a channel for each dimension. And we don't need alpha because it's of absolutely no use to us here, so we can take that out of our top two. We go to top two and then the alpha position here, remove that. So we've just got these three channels that we need. And we've got 6,400 positions. Wonderful stuff. So the next thing we need to do is rename these to something a bit more meaningful that isn't RGB. We need to change this to TXYZ using the T-script notation in the rename here. So this just takes 1, 2, 3 channels and converts them into T, X, Y, Z, like that. And they need to be named this way to be used with the object chop as well, just so it understands what's going on. So we're going to pop in another object chop here, pop our fish in the top and our reference in the bottom. And on our output for this chop, we will go compute measurements again, turn off position, and instead use bearing. And this will start to give us the angle that the fish need to be rotated to face the force that we're following around. The trouble now is we've only got one value and we need all of these values, and that's because this doesn't know how many things to compute. So we need to go to channel tab here and pick on the output range and go start end, and then drag our rename into here like this to get a reference to it. Change this to samples and then go dot num samples -1. Now we've got rotations for every single one of the fish to point to this position here in the of the force. Amazing, and they're all named R, X, Y, Z. Lovely stuff. So I'll null that off. Call this rotations, and then we're going to drop this into our geo under the rotate op here, and then we'll change these to RX, RY, RZ. And now, as if by magic, all of our fish are facing in the direction of the sphere. How cool is that? This is one of my very favourite chops at the moment. I really love the object chop. There's so much cool stuff you can do. If you go to output as well, you can get distance and you know, lots of other things that you can play around with. Totally awesome. So you can see we're almost there in terms of you know, what I showed you before. It's looking pretty close. So what's the next thing we need to do? So on the original, we kind of have the camera living inside of the school of fish, you know, as if a diver would on something like you know, one of David Attenborough's programs like Planet Earth or whatever. You know, they're down there under the ocean with a torch, you know, looking at the fish from the middle of the school. So that's kind of what I wanted to replicate with the camera work in this particular example. So the way we can do that is create a camera. We're going to make another camera here, there, and we're going to call this fish cam. What I am going to do is I'm just going to turn off all these fish undulating around so that I don't feel sick. So we're going to call this fish cam here, and what this is going to do is basically look at one of the fish in the school, and that'll create this illusion that we're kind of, you know, doing the camera work, following the fish in the direction that they're going. So how do we do that? Well, we've got our fish cam. That's the first thing we need. Let me check and I've got my notes here for any settings that need to be changed. I think we're fine. I think I had the FOV set on this to 40, so just change that. But I think that's probably negligible. So the next thing we need is a null here, and we're going to call this fish lookat. So this is a null comp, and this is going to be the position of one of the fish that we want to follow. And we can get the position of one of the fish that we want to follow by digging into this bunch of fish positions here in this rename that we've pulled out of the texture. So what I'll do is pop down a select chop, so we just can reference this. I'll pop that on there like that. So now we've got our positions down here, lovely. Null this, and then inside here we can use a trim and just pick out one of the fish. So we've got current settings here, relative to start and end and start and end. And if you go samples and change this to absolute, then we've just picked the first fish in the list. So this is like this sample here, the very first one. And what I like to do is right click on here, copy the parameter and bind it to the end parameter. So then I can increase this value and just pick different fish. You know, and we can sort of pick one that gives us the best view for when we want to make a video or whatever. So we've got our fish look at, we've got the point we want it to look at, so we can just drag these in here and do chop reference on X, Y, and Z. And now our look at is following one of our fish. It's sort of sitting in the same position as one of our fish. So on our fish cam, if we go to transform and drag this fish look at into the look at parameter there, now if we look in here, we can see the camera is following one particular fish. It's not totally obvious just now, but it will become obvious eventually when we see, you know, you tend to eventually be able to pick out which particular fish it is that it's following. If we hang on a second, we'll figure out which fish is ours. It's this one here. There it is. Look, there we go. Whee! So what I like to do as well, to make that less obvious for when you record a video, is here you can pop in a lag chop, and this will just create a bit of a delay. So I do like lag and do it to like 1 in each direction. Then the camera will just sort of lag behind that fish a little bit and make it less obvious that it's following a fish, and you know, not destroy the illusion that we're after. So what have we got now? I think that's everything we need camera wise. Let's have a look at our render and change the camera from cam 1 to fish cam, like this. And then if we go back to here, okay, there we go. I'm also going to change our camera's position from 5 to 0, so it's now sitting in the center of the school of fish. There we go, look at that. So, yeah, so this is kind of giving us basically the effect that we've been after, and we can just tweak this a bit now, but the fish are, you know, floating around and following that ball. What we can do as well, we don't need to be able to see that sphere anymore, so we can turn this off here with these 3. This is the pickable one, but I'll just turn them all off anyway. So that gets rid of that, so the illusion's not lost. What you will notice is the fish are quite dark at the moment, and that's just because we've got one light up here that we don't really need, because this is set for this camera, and we don't really need these anymore, so we can get rid of them. And now we've got no light, obviously. But what we can do is, you know how I said before about having that, you know, the diver with the torch following the fish around, we can recreate that as well with a light down here. So in the same way that we've got our camera following this look at, we can also have a light following this look at as well. So we can click on our light, go to the look at parameter there, drag our fish look at on, and then set this position to 0, 0 as well. So now our light is always going to be looking at that same fish as the camera, and then we can adjust this for whatever sort of stylistic needs that we like. So I haven't tried this, but if we do a cone light, you know, we could get sort of like quite an interesting effect as well. You know, we get a bit of the vignetting or whatever it's called around the side. Whatever we like, really. So yeah, that's quite nice. And we can change the dimness here if we need to, and we could also even change the color of the light to give it more of a underwater vibe if we so chose. I'm just going to leave it all white light for now. So the last thing you'll notice is the fish seem a little bit subdued, a bit dead, and that's because they're in this fluid simulation, and fluids tend to flow quite smoothly. There's probably a setting in the solver somewhere in the properties that you could play around with to create a bit more chaos in the school. But what I've done to recreate that feeling is just in between our Nvidia Flex top and the positions that are going into our instancing, we can pop a noise in here, and that'll just give our fish a little bit of wiggle. So in here we go insert and then a noise, and change this to monochrome off, and our maybe we can leave the offset as it is, and in the transform, go to Z, do ABS time.seconds times 0.1, and that gives us quite a lot of wiggliness actually. So maybe we could go down to 0.05. There we go. So that kind of looks a bit more like a nice friendly school of fish floating around. The other thing, just to kind of polish this off a little bit, all the fish are the same size at the moment, so we could quickly create something that allows us to vary the size of those fish as well. And the easiest way I find to do that is just with another noise top here, and set this to the same size as our fish positions. So on the common page here, if we drag this into here and do dot width and copy that into here and do dot height, that gives us some values that we can use for scaling. Change this pixel format to 32-bit float and then null this off. Oh, I've put a notch top in there. Null this off, and we'll also want to range the sizes a little bit, because these are all values between 0 and 1, but we don't want our fish to be 0 scale. So in a math top, we can go to range, change this to 0.5 being the smallest fish, and maybe we could have a scale of 2 for the biggest fish, and then we'll change this name to scale. So now in our instancing on our geo for the scale op, we can drag this in here and change this to RRR, and that will give us some different size fish now, which is nice. I think our initial fish size is a bit too big as well, so let's just knock that down a bit to something that seems reasonable. There's a lot of fish, a lot of fish. Let's go with something like that. That looks okay. It's nice and spacious. So one last thing to kind of create this illusion of underwaterness is on our fish cam we can add a little bit of fog as well, which is what I did to kind of create, like, just give us the light that we need to see the fish that are closest up. So on our fish cam, if we go to settings and fog, linear, change our fog color to black, and you can see the effect is already there. I like to bring the near out a bit. Let's see how it goes. So bring the fog far in to something like this. There we go, look at that. Zoom out here. Yeah, there we go. So something like that, so you just get the fish that are close up. And I don't think the near is really gonna, we can brighten up the stuff at the near a bit if we change that to something like 2. Lovely. I feel like our fish are a bit too feisty. I'm just going to change this to 0.25. Maybe now they're not feisty enough. I don't know. There we go. Anyway, that's the effect that you need. So the overall principles here are using the Nvidia Flex stuff, not for your traditional fluid simulation, but to emulate something else, and then being able to take this position information out of this texture and do your own manipulations to it as well. So here we're just adding a noise, but I've done projects where you can take what's going on inside of Flex and then use a blend chop or a cross chop and take that liquid information and transform it into different geometry shapes, and have those geometries kind of wiggle and move around, but driven by Nvidia Flex instead of a standard noise, and you sort of get some very cool and interesting effects. I think that is absolutely everything on here. So what I will do is I'll take this project and I'm going to upload it to my Patreon, which has currently been just part of my Twitch channel. So I stream on Twitch under twitch.tv/thoseeyes and do lots of TouchDesigner-y stuff. and do this like 3D show sometimes as well. And then I've got Patreon here, patreon.com/those eyes, and I'm going to start putting my tutorials on here along with the project files for people to grab, but the videos will always be free on YouTube and the internet in general as well. So I hope that this has been useful. Please let me know in the comments if you like it or have any questions or anything like that. Subscribe, like, follow, all of that lovely stuff. Thank you to everybody in the TouchDesigner community for getting me started on this. This is why I wanted to do a tutorial, to give something back at least. I hope this has been useful, and I'll see you later. Thanks very much. Bye bye.